Hi, welcome to hands-on KNIME session on unsupervised learning. Today, let's talk about K-means clustering. This is an unsupervised learning machine learning model, which means that there are no labels in the data. That we will have to use the features in the data to create the homogeneous groups. So let's start with picking up our data set. So let's bring the data set into the environment by configuring the CSV reader. Today we are going to see a small data set. Let's execute and see. The data set has got 10 rows and 7 columns. The cust ID, name, this data set is talking about the monthly visits to the store, the average monthly spend, and the items bought in terms of staples and other stuff. So this is a customer spend database, a small database of 10 rows and 7 columns. And as you see, these are all numerical variables, and this is the categorical variable. There are no target variables. This is a data set, and then we, by using the k-means clustering, we will have to group this data set. So let's see how do we do that. So as you see the data set, first thing is that we need k-means clustering works with the numerical variables. So here we have a categorical variable which is a name, and the name doesn't bring a lot of value into the clustering. So let us see what are the variables that we want to use for the clustering by filtering out the unused columns. For that we will use a column filter. Let's connect. What do we want to exclude? Cust ID doesn't bring much value. Name also doesn't bring value to our segmentation clustering. So let us remove those fields and apply and execute. So now the table looks like we have 5 columns and of course the 10 rows as is. So if we just take a deeper look at the data, so the scale of the every monthly spends is in thousands, and the scale of the rest of the columns are in in tens, like the value range of 1 to 10. So if we have a data set like this, it is very difficult to bring the normalization. So we will use the normalizer to bring the uniformity, to bring all the variables into a common scale. So for that we will use a normalizer node. What type of normalizing? We want to normalize all the variables in the range of 1 to -1. For that, we will use Z score normalization. Now, if you see the data, let's see how the after normalization, the range of the data, all the variables are in the all the columns are in the same range. So now this helps us to create good clusters because the data is normalized. Now for clustering, let us use the clustering node. K-means clustering node. So let's see what do we have to configure here. So for clustering, we because we have filtered out unused columns, we will use all the columns here, and then the configuration that we can give is the number of clusters. This is what the K refers to in the K-means clustering. So by default, it has configured 3 clusters. So let us try how the clustering looks like with 3 clusters. Let's see how the table looks like now. If you see the data now instead of 5 columns of in earlier that we passed on to the k-means clustering, it has created one more target variable which is a cluster. Now the data is placed, it has normalized the data. After the normal data is normalized, it used the k-means clustering, the Euclidean distance, to calculate the distance between these columns and the data sets, data points in the table, to create the this 3 clusters that you see, cluster 0, 1, 2. So this is how the K-means clustering operates. If you want to have a look at the number of clusters, see these are the three clusters. Now that the data has been clustered, now there are three clusters. So now we can find some insights from the data by looking at how the clusters have been formed. If you look at this, the number of visits in cluster 3 is more compared to rest of the two clusters. But you can infer that the average spend is less. Though the customer visits are more, the average monthly spend is less. There are some customers who are like not visiting the store, but their monthly spend is more. So these are the kind of inferences that we can draw by doing some kind of exploratory data analysis post clustering. Okay, because the whole intent of clustering is to group the data. Because this is unlabeled data, there are no target variables, and then we want to bring some kind of homogeneity into the data set by grouping them into the similar blocks or chunks of data. Now, to do the data exploration, as we have seen in the earlier videos, we can do a lot of stuff. But for the sake of today's session, let us see how the scattered plot looks like. Because we are dealing with a lot of numerical variables, let us see uh, how the scattered plot will help us to decode some of this inferences. Now we are trying to evaluate, because this is a scattered plot. We will have two numerical values both on the x-axis and y-axis. We have configured that, and let's see how it's looking like. So this is how you see the scattered plot looks like. But because it is of the same color, let us see how if these are like no, if we are not able to identify which cluster is what. So let us use a color manager to color each of the cluster. After, let's connect the color manager and configure the color based on the number of visits, and connect it to the scattered plot, and then see how our scattered plot looks like. As you see, this is how the clusters are being depicted in the scattered plot. So to summarize, Kevin's clustering is a popular unsupervised learning technique. It uses the Euclidean distance to create these clusters. The only configuration that we have to give for K-means clustering is identifying the K, which is the number of clusters that we want to create. Most of the times, this is done based on the business understanding. And to arrive at number of clusters, the optimal clusters, we also have the elbow method and Shillot method. Though this help us to though this help us to arrive at the value of k, it is always advisable to do it kind of trial and error, have a business understanding of the problem that you are dealing with, and then see how many clusters can be get data can be categorized. And it is always important to do a kind of data exploratory analysis post the clustering, because that is how we want to group the data and bring some insights for the business. So that's it for today. Thank you for watching. See you in the next video.